Guys got everything tied down back there? Yeah.
Yep.
We're going through the lee of St. Elias, so there might be some turbulence.
Fasten seatbelt sign on.
Well, who am I to tell you what to do?
There are tens of thousands of glaciers in Alaska. Some stunning cliffhangers, others wide glaciers that come down to meet the ocean tides. Some, like this one we flew over in August, are easily visible from low Earth orbit and are mesmerizing from 1,000 feet above and have trees growing on top of their soil-laden boundaries. Those glaciers, although they represent only a fraction of the world's ice, are contributing much more than their share to sea level rise. Chris Larson and his colleagues have repeatedly measured 220 of them in a small single-engine otter, measuring their height with lasers and their depth with radar, and watching them change from season to season and year to year. But Alaskan glaciers are also different. We're only just figuring out how they all behave. Data from flights like these, part of NASA's Operation Icebridge, can help fill the gaps. Chris and radar specialist Martine Trufer are both from the University of Alaska Fairbanks and both seasoned Alaskan pilots. But they rely on their good friend and legendary bush pilot Paul Kloss and his 35,000 hours in the cockpit to fly the incredibly demanding flight lines the mission requires. And does it help you guys being pilots too?
I would like to think so, but watching Paul fly and seeing what he does, it's kind of like trying to learn quantum mechanics in kindergarten.
You know, I can fly my airplane around, but just seeing what Paul does in this extremely challenging environment in the mountains while trying to follow a specific flight line at a specific altitude above ground, negotiating winds, topography, maybe occasional low-level clouds that you have to get around, and just managing all that is just several levels above what I could do as a pilot.
Well, I think the first time I came here to this park, I was probably 4 years old with my father. I've been blessed to be able to fly in lots of places in the world, all over the place actually, almost every continent. I guess I'm always looking for some place that might be better than this, but I haven't found it.
Paul's plane is about 60 years old and is the first single-engine otter ever retrofitted with a 1,000 horsepower engine, which makes takeoffs feel effortless and gives Paul the ability to negotiate wild terrain, which he certainly did during the first 2 incredible science flights of this campaign. And with sunny skies and relatively calm air, we covered 3 vastly different pieces of ice. While Paul fueled up the plane, Chris gave us a preview of the day's science and scenery.
So it has one of the greatest coastal reliefs anywhere in the world. So it's between the ocean and the summit of Mount St. Elias, which is 18,008 feet high. It's less than 10 miles. There's a stupendous amount of mountain right off the ocean. It's hard to beat it anywhere in the world. It might be the prettiest for me. It's absolutely stunning. From here in McCarthy, we'll cross one of the bigger precipitation gradients in Alaska too. Here it's about 10 inches of precipitation a year, and we'll go over to an area where it's on the order of 200 inches per year. So it's from one of the driest parts of Alaska to one of the wettest parts of Alaska in about 45 minutes flight time.
Whoa, that's pretty good.
That's awesome. You want to do Tyndall next?
Sure. Where are you on?
If the winds are calm now, might as well grab it.
First, we came to the rugged landscape of Icy Bay, which not that long ago wasn't a bay at all. It was filled with ice. Tidewater glaciers in this region can make dramatic advances and retreats as they feed on high rates of snowfall and then retreat as they're melted by warm ocean waters. Like the Tyndall Glacier seen here, most of these glaciers have retreated dramatically over the last 100 years. But nearby Yahtzee Glacier, after years of retreat, is currently the most rapidly advancing glacier in Alaska. Overall, though, the Icebridge Alaska surveys, from the Denali region in the north to the Juneau ice field in the southeast, have documented pretty substantial thinning of glacial ice. Areas seen here in orange and red show between about 10 and 15 feet of thinning per year.
1200.
There's a nice waterfall up there from the hanging ice.
When we very first started profiling this, Paul, this gravel fan in the one in the valley next to it didn't exist.
Yeah, I was gonna say,
this was
look
deep.
at all the good landing spots here.
Yeah,
There's no place to land here before.
no, it was deep water.
After covering several of Icy Bay's glaciers, given that it was time for lunch, just like that, we landed in this unforgettable spot. Flying eastward, leaving Icy Bay behind, we came to the mighty Malaspina, one of the Earth's great examples of a Piedmont glacier that spills out like pancake batter onto a broad plain as it approaches the sea. It surges at uneven intervals, creating dramatic patterns on its surface as it distorts the moraines of rock and soil borne along by the glacier. The Malaspina is less dynamic than the Yahtzee and is only melting at about the average rate for Alaska, but that could change quickly.
It has the potential for being one of the bigger geographic evolutions in Alaska. Certainly my son will be able to witness some big geography changes there. There's potential for it being connected with the ocean through some narrow lagoons, estuaries, which would take a little bit of coastal erosion, but it's not too hard to imagine that where the Malaspina Glacier is now could become a large bay.
The data that Martine's radar provides could reveal how vulnerable the Malaspina is to melting by the nearby ocean. Here we see the radar returns from the surface of the glacier, and here is something that Chris's lasers can't see, the rocky bed of the glacier, giving us both clues as to what's happening under the ice, as well as a measurement of its thickness. Finally, we came to the Yakutat ice field, 300 square miles of absolutely doomed ice perched high in the mountains. Researchers even debate how this ice field came to be at all, since in its current configuration, it's hard to imagine how it could capture enough snow to form glacial ice. And so, even if the Arctic weren't warming faster than the rest of the planet, this area would be likely to melt within a century or two. But with many other glaciers, it's easier to see the connection between a warming planet and ice loss. Thanks to data from Icebridge and other surveys, we now have a good estimate of the current rate of loss from Alaskan glaciers, 75 gigatons a year. While airborne observations over Alaskan glaciers have provided a rich record of change in the area, those efforts are now augmented by NASA's newest ice measuring tool, ICESat-2. With 6 laser beams of its own, and orbiting the Earth every 90 minutes, the satellite will carry on the record of Alaskan change. For their part, Chris and his team will continue to do their surveys for at least the next 2 years, helping to validate the ICESat-2 data and make further detailed observations over the stunning glaciers of Alaska.